Hello everyone and welcome back to AtMan Unlimited. We're going to be in the office today, and what I'd like to do is just review how I designed and went about modeling the 1000 subscriber play button in Fusion 360. Now this isn't going to be a in-detailed video, but I'm going to just generally walk through the timeline of the design and how I did it. But before we jump into that, I just want to make a few announcements. We do have a viewer that would like the monstrously large desk trophy, and that viewer is Rob. And Rob is a supporter of the channel, so we appreciate your support, Rob. Rob made a very generous donation to the channel, so thank you. And he also has a YouTube channel. His YouTube channel is Riflesmith1. That's a numeral 1. And I'll put his channel link in the description below. And he also has a website. His website is skirifles.biz. So thank you, Rob, for the support, and I hope you enjoy the play button. If you find it boring, sorry. Okay, so the other announcement I like to make, we've been doing a lot of machine maintenance. And the machine is running better than ever. I've got a little bit more maintenance to do to really get it up to snuff, and we're going to be able to turn out some really good parts coming up. I also made some really nice videos on the maintenance that we did. It's going to take me a little bit to edit them and get them in the can, so bear with me and we'll have some cool maintenance videos coming up. Okay, so that's about it. Let's jump into Fusion 360 and go through the design process of this play button. This is the 100 subscriber play button that I made back in August. Originally my thought was just edit the sketch and replace the 2 zeros with a K and repost the cam and the letter RIP. But that video got about 200 views as of the making of this video. I didn't think it would be very good content given the much greater maturity of the channel. So that's when I thought, you know what, if we're going to make this corny joke and make this part, we're going to have to, rethink this and make something a little bit more fitting of, what the channel's become. Now I like this, and it was a nice little plaque. Don't get me wrong, but it lacked, complexity. So that's when the wheels started turning and I started to design the 1000 subscriber button that we saw get made last week. Let's take a look at that model and we'll go through the design and kind of how it, matured and grew. Here is the model for the 1000 subscriber play button. Now this is the first, I'll call it, more complex design that I have done 100% completely in Fusion without having to use any other external CAD software. I didn't run into very many issues and it went fairly smooth. I've done a lot of other modeling in Fusion of more complex parts that have a lot of geometry to them, and I've run into issues there. But with this design, I didn't run into any real roadblocks, which is good. And I think that's part of Fusion becoming more mature, let's call it. One thing I do like is the timeline, so we can scroll back all the way to the very beginning and how I started this project. And I started this project basically with the idea of having some rotating numbers. Let's go all the way back to the very beginning. Alright, so very beginning, I just made a sketch and I plopped down some text and then I extruded a number. Okay, so you can see the sketch there, and the number. Now, one thing I did not notice, and I think Fusion needs to work on this a little bit better, and I didn't notice it until I actually machined it. If you zoom in real close on a large number or text that you use the Fusion text tool with, you will notice that they're not doing a very good job on splines combining one face to another. So you get this little faceting going on. And I didn't notice it because you really can't see it in the model unless you zoom way in, but you see that in the final machined piece. So that's kind of just a small complaint I have that they have to work on is getting rid of these facets when you're supposed to have a nice flowing curve. You look at that at face value and it looks really nice, but it's not. You can see these facets plain as day in the final part. So wasn't too happy about that. Now, once I made the number and I got the font, I took the font from the previous 100 subscriber model because I kind of like that font, just like the way it looked, and it's conducive to machining. I kind of had to figure out sizing, so sizing was an issue. So I wanted these to spin, and I kind of wanted them to counter rotate so they kind of, you know, dazzled a little bit and looked cool. And I also didn't want to go way too complex, so I thought the easiest way to do this would be with 4 spur gears on the bottom. And I figured the easiest way would be to buy large spur gears so that each number would have its own gear, and then the gear pitch would dictate the spacing and size of the numbers. So that's when I went hunting for gears, and I also didn't want to break the bank, so I found this company called SDP/SI, the Stock Drive Products and Sterling Instruments Company. And they sell tons of gears of plastic, brass, steel, different sizes, different cuts. They got a lot of them in stock, and I found these Delrin, you know, it's basically nylon 6/6 gears, and they were about $2 or $3 a piece. They were, you know, very cheap. They were in stock, and they had a gear pitch of 2.5 inches. So that's what drove the size of the project. It was all around the gears. You know, having a source of gears that was cheap and in stock was the key. So once I had the sizes, then I kind of knew how I wanted to make the numbers. So then I went and I started just modeling all these numbers and getting the numbers down and kind of moving them around. So there we've got the numbers. Just to spruce them up a bit, I just added a standard chamfer. I think it's 50 thou chamfer on each side. And then I modeled the base. So that's kind of how I started. And you know, I messed around with these dimensions a little bit. It doesn't show in the timeline, but I moved them in and out, and you know, came up with some spacing. And then I started making some sketching to put some holes in the base and to do some more extrude. So I had to hollow out the bottom of the base to hold, you know, all the stuff that we were going to put in it. So we hollowed out the base and then we put the holes in it. Now the hole locations are again driven by the gear pitch diameter. So just like with screws, you have a pitch diameter that's the center between what you would consider the outside diameter of the screw and the inside diameter of the screw thread. It kind of runs in the middle. Same thing with gears, the pitch diameter runs in the middle, so if you space them apart at their pitch diameter, you'll get the correct mesh, and then the gear manufacturer tolerances their gears so that, you know, given the tolerance of your holes, they'll mesh, you know, it all works out for you. So that's what drove the hole spacing there. So then we went to McMaster Car and we found these little oil impregnated bronze bushings. So these are 1/4 inch ID, 3/8 OD, and the OD is a plus 1 to 2 thou. So if you ream a perfect 3/8 hole, they'll have a nice light press fit. Here's the part number if you're interested. So then we duplicated and made a whole bunch of them. And then we put some joints in to put them in their holes. So that's where they are. Now again, the other thing you didn't see on the timeline is I adjusted the joint so that I had the right amount of height stick out so that the number will ride on this face of the bushing and the gear rides on this face of the bushing, and that's what sets the gear height in the back, and it makes it so that the numbers don't slop around. When I mounted the numbers onto the shafts, I did leave a little tiny bit of clearance in them, so there's a little jiggle just to make the motor easier to be able to drive it. So from there, what we did is we had to add the holes to the bottom of all the numbers to accept the shaft. So we made some more sketches and made some more extrudes, and you can see we added the holes to the bottom of the numbers. So 1/4 inch ID on the bushing, we went with 1/4 inch shaft, so I ordered stock 1/4 inch D shaft from McMaster Car. Again, I'm just trying to use stock supplies. Let's see here, and then from there we modeled the shafts. So the shafts were very easy to model, just a circle with the flat cut in it. And then we made more of them, and then we started to glue everything together. So we joined the shafts to the bottoms of the numbers, and then we put the shafts in the holes. Okay, so that basically consists of the top assembly that you see in the finished product. So we're moving right along. So now what we want to do is we want to start making this stuff work. So we grounded the base. So now that the base is grounded, you can take any number and spin it. Okay, so I made all these joints rotational so that you can spin them. Now what we did is we went to the gear manufacturer, that same website, and the really cool part is every single gear that they had listed that I looked at had a 3D model. And that was the other reason why I used their website and that company specifically, is because more and more companies are jumping on the bandwagon of making 3D models available. So to get to this point in the model, we just had to do text, we had to extrude the text, we had to make a rectangle body, and we extruded out the body, and then we imported parts. We imported. So this alleviates a lot of the time of modeling. I was not going to sit here and model that gear. I refuse to do it. I'm not going to do it. I think a lot of time is wasted in industry today trying to 3D model every single minute detail to get this beautiful, perfect model, but at the end of the day, all that minute detail doesn't serve a purpose. I'm all for 3D modeling if the model gains you insight and information that you need to judge your design goals and your design robustness. You know what I mean? So we put the gears in, and then we duplicated them all, and then we put them on the shafts. So those are all just assembly joints, just like you would any other part. Now at this point in time, they're not linked together. The gear is linked to the number by the joints, so the number is joined to the shaft is joined to the gear as a rigid, and then the shaft is joined to the bushing as a rotational. So that's the joint layout right now. So then the next thing to do was to put in motion references and links. So we added in 3 motion links to link each gear. So now with these motion links in, when you rotate one gear, they all turn in their respective directions and their respective amounts. And the really neat thing is if you take that 3D model and you make your joints right, you can literally watch the gears meshing and unmeshing, which I think is really cool, because then you can make sure that, yeah, okay, I've got a little space here, my pitch diameter is right. And that was the value of adding in the gears, is 1, to make sure that my pitch diameters were right, and then 2, I wanted to see how this thing looked. If it looked stupid, I was going to stop here and not make it. Why bother? So that's why I started with all this stuff first. So let's move on. What do we do next? Okay, so next was figuring out how to actually make these things spin. I didn't have a lot of space here, and you know, relatively speaking, there's not a lot of space here for all the stuff that we stuffed in the bottom of this, but also is we're very limited on the Z height. So this is only, from this face to this face is only 0.6 inches, a little bit less, 0.575. Here, we'll measure it. 0.575. So our material was 0.75 rough stock. We took 50 thou off the bottom to square it, and 50 thou off the top to square it. So that left us with 0.7, and then we left an 1/8 inch material for this part here to hold the bushings fairly good. So this isn't the ideal situation, but what I ended up doing was using a, where'd it go? Using a worm gear, okay, that interfaces with the spur gear. Now this isn't, like I said, this isn't an ideal situation. Most of the time when you interface with a worm gear, you want to interface with a bevel gear that matches the worm gear. But as long as you keep your pitches and your gear tooth designs common, doesn't say on the bag what gear tooth profile these are, but as long as you keep them common, you know, it will work. There's almost no torque here. You know, they're plastic gears. It'll be fine. So then we went and we tried to find the motor. So then we added the gear motor. So there is the gear motor. That's kind of stuck. I haven't positioned it yet. And the gear motors I got from a website, Palau website. It's a you know, electronics, robotics type website, and they sell these little tiny gear motors, and they're only 10 or 15 bucks depending on which one you get. And they're actually pretty good little motors. They've got quite a bit of beef to them for their size. This is actually the motor I use to drive the focus in the dive light, so that's where I got the motor, you know, from. I searched around for a nice, reliable, you know, tiny motor that had an embedded gear drive in it, and you can get these anywhere from a 3,000 RPM output shaft all the way down to 150 RPM. So they've got quite the range of gear reductions. So now once I had the motor, I kind of started messing around of where I'm going to put the motor and how to structure the gears. Originally I had the gears in the center, then I offset them to the rear wall, and then I started, you know, kind of figuring out where everything was going to go. So then I needed a motor bracket. So this is the motor bracket that you kind of saw get made in the flood of coolant, and basically it just screws down to the back side of the base plate with two 440 screws, and then this here, they're metric. They're like 1mm screws or something like that. So there's two screws, and then the shaft comes through here. So there's the motor bracket. And we started doing some more sketch work and making some more parts in here somewhere. Oh, I started cleaning up the front. So once I found out that, yeah, I'm going to make this thing, the timeline's not capturing this quite right because this gets moved off later and assembled. But once I figured out I could make everything fit, then I started to pretty up the front of it. So I added these bevels, and then I just added some chamfers to them and some radiuses to them. And that's what gives it the really nice finished look. You know, it looks like a finished part now. And then by wet sanding these, it takes off the sharp corners and it, you know, kind of rolls them a little bit. So after it came off the machine, I wet sanded the face of it with 400, 1,000, and then 2,000 grit, and then polished it, and it came out really good. Didn't take too long, maybe about an hour to progress through all the sandpaper and then to polish it. So, you know, not too bad. So then on the back, I started to do the mounting. And again, the timeline doesn't reflect all the iterations I went through, so I moved a lot of this stuff around, you know, trying to get it to fit. Originally I had the motor positioned the way it is now because I was going to drive this end gear, you know, with the motor facing this way and the gears were centered. But then I was like, you know what, it would look a lot better if I was able to put all the text in the front, offset the gears, or offset the numbers more towards the rear of the part, and then by offsetting the numbers towards the rear of the part, it gave me this whole big area here to put all the other components and electronics. So that's when I started making these little extrudes and holes here to mount everything to it. So I just modeled my threads, and then I started putting stuff in the right spot. So now the motor is joined to the bracket, and the bracket is joined to the base, you know, based on its mounting holes. And now it's starting to look like an assembly. Then I put the subscribers text in there. And then I put my logo in there, and then I traced out the play button logo. Then I started working on the play button logo, so we extruded the triangle, and then we put the fillets in for the triangle. And again, these fillets were driven by the end mill size. 1/16 of an inch end mill is the smallest I like to use commonly. Any smaller than that, you start getting a lot of issues. So these are, I think I set these to 35 thou radiuses. And then after that, I think we made some more joints on the bottom again. Yeah, I joined the screw. The timeline's not exactly how I did this. It's kind of jumping around a little bit. I don't know why. So after I extruded the hole for the play button, then I went and or at least the model shows that I joined the worm gear to the motor, and then I made another motion link between the worm gear and the motor. Now this motion link is a little bit tricky because for every one rotation of this worm gear, the spur gear isn't going to turn one rotation. So you've got to put these angle references in here between the two parts. So for every one rotation of this part, we want this part to turn 3.33333 degrees. So that motion reference, figuring that one out was a little tricky, but you got to do the math based on the gear ratios. And again, the modeling is great because you can see, you know, how close you've got the worm gear to the spur gear, and then you can move it and you can watch the spur gear teeth kind of go in between the worm gear teeth, and you can see that you're not going to have any real bad interference issues, and then, you know, this is going to work. So having those motion links in there and being able to do this in the model is really cool. I didn't make these all spin. I stopped there. This is a bought part. Again, I know it's going to work. You know, stop modeling when you're done. Don't keep going to make it, you know, pretty. Okay? So then, you know, all this works, and then you can see it all work, and that's real nice. So what do we do next? So we made the hole for the play button. Now the hole for the play button in this pocket is actually a little oversized. There's about 5 thousandths clearance between the play button and the base, and then this hole is oversized so that it can accept a nylon insulator. Once I had all this modeled, then that might be why my timeline's kind of screwed up. Originally I was just going to have the play button as a logo and not have it as a functional part of the design. And I was just going to put a switch, you know, somewhere on the bottom, or a push button, but I couldn't find a switch that would fit in the size envelope that was decent. So then I thought, I said, you know, it'd be really cool if you could make the play button work, right? And, you know, I mean, that really sets off the design, is by having that play button interactive and working. So I thought how I could do that. You know, as you found out from my bio video, I'm also an electrical and electronic engineer. So I went over to my bin of miscellaneous parts, and I kind of looked what I had, and I was able to cobble together a little flip-flop circuit and a logic gate circuit to detect just a resistive touch. It's not the best way to detect touch, but I didn't spend any money on it. I had parts in the box that worked, so we rolled with it. So once I figured that out, that's when I started down this path of the design of making this an extrude and a pocket, and then going off and making a button. So there's the play button. This was sketched out and then extruded, and the sketch, we just did project off of this sketch lines, and then we did an offset to make it a little bit smaller. You can see the clearance gap in there. Now we had to keep it insulated, so two things had to be done. One, there's a nylon insulator in the back here, and that's what fills this gap here, so it helps center the button, and then it insulates the button from the base. And then two, we used a material called Kapton. I have a Kapton tape. It's about 2/1000ths of an inch thick tape that is wrapped around the bottom of the button and then up the sides. And then once you push the button in, you can't see the Kapton at all, which is really nice. And also the Kapton is a goldish yellow color, so it blends in with the brass. And then also Kapton is an extremely good insulator. It's used heavily in aerospace. It's pretty pricey. A roll of Kapton tape is $20–30, but it does a marvelous job. It can withstand heats up to like 500 degrees, I think, or something like that. I'd have to double check. But so when this thing's glowing, the Kapton will still be in good shape. Alright, so moving on. So we threaded a bunch of stuff. We added the threads to the outside just because that's easy to do. Then I drew up and modeled the battery pack. So the big question was, will the battery pack fit? And there wasn't a model for the battery pack. Unfortunately, there was a drawing for it. This model isn't too bad. Basically, I just drew this shape, made an extrude, and then told it to, I used the shell command to shell it, and then I made another extrude that went across the top to cut it down so it matched the drawing. And we put the slots in it, so those are the screw holes for it. And now we located it in the part. So there's the battery container. Now I didn't model it, but I'm gonna have to put little tiny rubber feet on it, and I noticed this before I made it, but if you look at a profile view of it, you could just barely see the battery pack peeking out a little tiny bit. I just didn't have enough space to hide it all, but it's only a little tiny bit, and I was gonna put little feet on it anyway, because if you put this on a nice table, you don't want aluminum sitting on wood. You don't want to take the chance of it scratching, so we'll put little tiny rubber pads here. And that'll lift it up enough where the battery won't touch the table. Whoa, where'd my model go? There it is. Huh. Okay, so moving on. What do we do next? More extrusions. Not sure what that one was for. We put the holes in the back of the numbers. So, I was trying to figure out how to easily attach the numbers to the shafts. I didn't want to put holes in, but I also didn't want to be pressing the shafts in with the numbers, because I wanted to be able to try to control the alignment between the gears and the shafts as best I could. So I ended up putting little tiny set screws in the back of them. And then I actually used little button screws, and they kind of look nice. So that's the mounting screws for the numbers. We're almost to the end. We made them holes. Did the one for the number 1. This one was kind of weird because the number 1 isn't centered axially. It's kind of weird. I did that because when it was centered axially, the rotation didn't quite look right. The rotation with it not centered looked a little bit better, from a clearance angle. So I moved it this way a little bit so that the nose of the 1 would clear the 0, and then I didn't need as big a gap between this edge of the 1 and the 0. So it just helped it balance the look a little bit better. Okay, so then we started adding more stuff in the back. Then I added the circuit board. So I wanted to add the circuit board for a very specific reason. I used a cheap PC mounted slide switch here, and I didn't know if I had the space between the end of the battery holder and the nose of the switch to make it work. So I modeled the PC board, and then I added a switch, and I joined the switch. And that was the last thing I did after I modeled the PC board. So I put the PC board in there to make sure it would fit between the walls and the motor mount, and it lines up with its mounting holes. You know, big oversight that a lot of new designers do is they'll make a PC board and they don't think ahead on how to mount it. So then they make the PC board and they go to put it in their device and they're like, oh, forgot about that. So this is just double checking my mounting and then making sure the switch fits. So I've got more than enough clearance here. You can get your finger in there to turn it on and off easy. And then also what I found out by modeling the PC board, if I turn off the PC board and the switch, these originally were 1/2-inch radiuses in these corners, and with 1/2-inch radiuses this material stuck out too far and got way too close to the pins of the components on the PC board. So I swapped it out for a 1/4-inch radius with a 3/8 end mill, I believe. Here, just click on it. Yeah, 1/4-inch radius, and then I made those with a 3/8 end mill. And I showed the end mill profiling the whole outside here, and you can hear it digging into these corners as it's removing that little tiny bit of material there left over from the 3/4 roughing mills and finishing mills. So, you know, that was a big benefit to adding the PC board in here, because you can see now with those smaller radiuses, I don't have any, you know, clearance issues at all, and nothing's getting even close to the pins. So that's the entire model for the play button, and I probably talked your ear off. It was a fun project. It was kind of neat to do all this modeling and see it work. You know, you can do a motion study on it and then have it play by itself, which is pretty cool. So you know, it was a good practice part if you're wanting to learn about joints and motion links and then motion studies and everything like that in Fusion. So I thought that part worked out really good. If you want, I can post this model and make it public if anybody would like to look at it in hand. I think I'm going to do 2 more videos on this. One of them I'll review the cam. So the cam is an absolute mess. So you can see all the different setups that we did to make all these different parts, and then there's some more for some soft jaws, and then there's also some more for the PC board. So I'll go through the cam in another video to kind of review what my thought process was in machining it, and how I set it up, and how I cammed it. And then also, if somebody already specifically asked on information on how I machine the PC board that you saw in the video. If you're still with me after all of that, thank you. I understand some of it might have got a little bit dry. You know, no other way to really make this video and kind of go over things. So the next videos, I'm going to make one for the camming and how we did the cam on this, and then I also will go over the PC board, and I think a lot of people are interested in the PC board aspect. So I might do the PC board aspect before the cam, just kind of mix it up a little bit. So thank you for watching, and we'll see you on the next one.